Hello, today is Thursday, July 15th, 2021. My name is Daniel Mullany, and behind the camera is Diego Juarez. Today we are going to be filming a video source inspection of a new 480S spin rinse dryer. Our customer's PO number is 102262-F, and this system will be shipping to the East Coast of the United States. Well, actually more central, but that's okay. Here we have, as I mentioned, a brand new 480S spin rinse dryer. It has our SciTech proprietary control system hooked up to it. It is configured for 8-inch substrates. It has all the options for it, which are anti-static, DI recirculation, and resistivity. I'm going to be running the system, and then I'll discuss as we go. Okay. All right, so now that we are running the tool, we'll go ahead and discuss the system as we go. So this is a 8-inch capable spin rinse dryer. It uses a low profile 8-inch cassette. Here on our touchscreen, you can see the process that's currently running. Right now we are in our rinse process, which runs at 500 RPM. This is our recommended rinse speed. During the rinse process, you'll have the rinse valve open, which allows the DI water to do a quality rinse over the substrates, as well as the LPP valve, which is what we call the low pressure purge valve. The low pressure purge valve is what's going to be continuously blowing a light flow of nitrogen out of the heater manifold to ensure that none of the water that's currently splashing around the chamber works its way back up and into the heater. So this is typically a 60-second or so cycle. We are almost finished with that. Next, we're going to be jumping into purge. So here we are now entering the purge step, which during purge, we're ramping up RPM to our high RPM set point, which is 1800, while purging any of the residual DI water that is left in the DI manifold. Our objective here is to make sure that there is no residual DI water stuck in the manifold that would leak out or drip out during the dry cycles. Dripping water such as that during the dry cycles could lead to water spotting and inconsistent drying results. So now we're in our dry one portion. So during dry one, we are going to spin at a high RPM, typically about 1800, for a short amount of time. In this case, it's 90 seconds. So in this minute and a half, we're going to spin at this high RPM, and our objective is to whip off the majority of the water that was on the cassette and substrates and rotor. So even though all the heating elements are going to be on during both of our dry steps, there's two dry steps, and even though the heaters are going to be on during both dry steps, the first shorter dry step is going to be high RPM. So as I mentioned, it's going to try to whip the majority of the water off of the cassette and substrates, so that way when we continue our drying, that we're going to get a nice uniform dry without any large droplets that are going to be potentially leading to staining or water spotting, as I mentioned before. So we've got about 5 more seconds left here before we drop into our dry 2. So this is our last step of the process and our second dry step. As I mentioned before, the dry 1 and the dry 2 are going to have the same heaters on, so it has the same heaters on, but now we're dropping down to a lower RPM, and we're going to rest here for now 300 seconds. So where we had 90 seconds at high RPM, we now have 300 seconds at a lower RPM. Now the heating elements are going to finish off the drying process to give you the best particle counts added from the SOD, as well as the most efficient uniform dry. So the one difference that we do have between dry 1 and dry 2 is that in dry 2, the anti-static unit is on. That's the static dissipative component that's going to prevent a high or a static charge from building up in the Teflon cassette because of the high RPM spinning. So basically, during this last dry step, it's going to be neutralizing the static in the bowl, so that way when we take the cassette out, particles in the room don't attract to the cassette and then latch onto the substrates. It's kind of the same concept as when you're rubbing a balloon on your hair and your hair pulls towards it. We want to avoid that condition. So we're going to use a static discharge to remove that charge and prevent the particles from migrating to the cassette and substrates. So we have about 210 seconds left here. So what I'll do is take some time to discuss some of the other products and services that Cytec offers. So Cytec has been in the industry for 20 years, and we are experts with spin rinse dryers first and foremost. We manufacture both new and refurbished spin rinse dryers. We offer control system upgrades, and we have 100% of the spare parts and services required to keep any SRD you have up and running. We are also the OEM for all Vertec spin rinse dryers. We purchased the company Vertec several years ago and are now the OEM for that product line. For the spin rinse dryers only. You may have questions about Megasonic or other Vertec products. That is not under our realm. What we specialize in, as I mentioned, are the spin rinse dryers. In addition to spin rinse dryers, we also offer a variety of other refurbished equipment to the front-end marketplace, the front-end semiconductor fab space. So that would be box washers such as the Floraware HTC 8000 series. That would be mask cleaners like KNS, Ultra T, and Ultra Tech. Mask cleaners can be used for cleaning particles off of masks. They can also be used for cleaning particles off of wafers or cleaning dust from in between diced wafers that are pulled onto a stretch frame. We also offer refurbished YES ovens for vapor priming. We offer refurbished photoresist pumps, Cybor and IDI, for use on tabletop spinners or industrial tracks. We also do microscopes, barrel ashers and etchers, and really a whole variety of equipment. What I just mentioned there was just some of the tools that we do, but as you can tell, we have capabilities in lithography areas, wet etch areas, deposition areas, dry etch areas, really kind of a variety. So if you're interested in any equipment like that, I would suggest taking a look at our website or giving us a call at 916-797-9000. Okay, we've got 75 seconds left here. So this system is running great, but one thing I want to mention too is that I noticed that at about 500 RPM, which is where we're running right now, the system has a slight bit more vibration. That's common for an SRD to have what we call harmonics. So a harmonic is a set point at which the rotor has a little bit more vibration. It's just the nature of spinning something at low and high RPMs. There's going to be points at which it vibrates a little bit more. So when process setting for this system in the field, once you actually have your existing cassette and your specific substrates being used in it, I would suggest trying different RPMs such as 400, 450, 500, 550, 600. Find that set point that really works well for your specific weight and use that for the SRD. There's no concern at all with the way it's running right now, but you really can't optimize it just by changing your RPM by 50. And that'll be great for long-term use of the SRD, for just generally reducing vibration, the wear on the bearings, and everything like that. Fortunately, these tools are quite robust, so even if they are vibrating a bit, they're still going to operate okay. Okay. Now, here we are. We've finished with our process cycle. Light turns blue at the end of the process cycle, and you can acknowledge by either pressing OK or opening the door. We'll go ahead and open the door. As you can see, we turned to yellow, which is now our idle state. Pulling out the cassette and substrates, everything is dry and nice and warm. The chamber inside is also almost completely dry with just a little bit of residual water. That's expected, so there's no need to necessarily go bone dry in the chamber. If you see a few drops, that's okay. So this is a successful process run. What I'll do now is take a quick minute as well to just give you a short rundown of the controller so that way you can program in the fields when it arrives. First, we'll just do recipes. Recipe 0000, that's the base password that can be changed under the settings. Now, when you're in the recipe, you can change the recipe number up here. And then to change any aspect of the recipe, you simply click the item that you'd like to adjust. So let's say that dry 2 RPM that I was talking about, instead of 500, let's try it at 550. Simple as that. Save. You can also turn on or off a Q rinse. A Q rinse will have the system continually rinse after the rinse period has finished if you haven't met a resistivity set point. So right now at 10.1 with Q rinse on, if at the end of your 60-second rinse the system wasn't reading 10.1 megohms of resistivity at a minimum, of course it could be higher, like 14, 15, you could be at that point, then it will continue to rinse until it meets that set point. So that's kind of a little quality control piece that you can use. The system will log if it uses the Q rinse at all, so that way you know that, one, the system made it through Q rinse, so the product worked okay, but two is that it took longer to rinse this time, so you might want to investigate what might have happened. And then lastly, you can have advanced controls by clicking on the actual dry step himself, saying, okay, we're going to venture out, and then you can use more advanced controls in here in terms of when you turn on the anti-static, the heaters, the nitrogen flow, or the bowl heater. I wouldn't recommend making any of these adjustments up front. Really, actually, if you're interested in making an adjustment here, give us a call first and we'll talk through what you might be trying to achieve and whether or not that's an appropriate way to use the SRD. Next, I'll just do a quick show. Here's the alarm screen. If you have any alarms, you can click on them here. And then if you come into the menu, again, all zeros, you have a variety of items here. Manual mode will be where you can go in and agree that you're now working in a maintenance mode. And here you can adjust, or you can test whether the valves are working correctly, the sensors, the heaters, the resistivity probe. You can run the motor manually. A variety of items in here. So this is great for troubleshooting. You can also turn on the N2 purge saver. We recommend turning this on, which I'll leave now so it'll be set on arrival. And then changing the N2 up to 300 seconds. So now at the end of every process run, the system will purge nitrogen for 5 minutes to cool down the heater, and then it will shut off that nitrogen waste. This is a great feature in order to prevent nitrogen waste in your fab. And lastly, if you'd like to jump into, there's more items here, but only one more that I'll really touch on, which is important, is the, let me see, go back here, is the logbook. So here in the logbook, you can choose a date. Because this system hasn't had the date program, you'll do that in the field. It's giving me, a 2000 date, but you simply set your date, press OK, and then jump in, and it will show you what has occurred on that date. That information can then also be pulled out of the USB port for more appropriate review with an Excel or a text file. So just kind of give you kind of a short rundown of the basics of the SRD there. Again, there's more features and more detail that you can experience with your own use of the system and reviewing the manual or giving us a call. So thank you very much for taking the time to review our inspection for today. Again, my name is Daniel, and I filmed this video with the help of Diego for SciTech Process Solutions. If you'd like to learn more, please visit our website at www.scitechprocess.com. SciTech is spelled S-I-T-E-K, or give us a call at 916-797-9000, and to reach me directly, dial extension 2201. Thank you very much, and have a great day.